to say, first of all, we are so grateful to our hosts, the Serbian HVAC Association, KGH. Thank you so much for your kind invitation. Thank you so much to have the patience to listen to our presentations. We prepare them with respect and with love for our profession, and with respect for you, your attendance. Thank you all for being here, and with respect for your time. So, non multam sed multum, said our old Roman ancestors. About me, I used to teach until 2006 in the Technical University of Bucharest. Then I founded my own company in consulting and design with a group of young students, engineers. Now they are 40 years old. They are among the very good engineers of Romania, may I say. In 2010, in a contest with 12 large teams of architects and engineers, a solution for this cathedral project has been selected. My company was with 3 of these teams of architects, and we won the first and the second place. May I say that the solution has been changed. First of all, we proposed heated floor between others, but finally, even if it was a heated floor with hot air, not with water, we were obliged to change because our main client, the Romanian Orthodox Church, didn't accept it to have air channels into the floor for many reasons. This cathedral is conceived to resist over years at more than 20 important earthquakes. Bucharest being situated in a zone with earthquakes as Serbia, Macedonia and Greece, so more than 8 on the Richter scale. So 1,000 years, that means fantastic structure, 1.5 meters walls, where at least 1 meter is reinforced concrete, reinforced at the highest possible level, I mean the percentage of steel. Page down, page down. So, about this building, 3 ground floors until -30. The main church at the ground floor, 123 meters is the height. The main church is normally 50-60 meters high, and it's like a huge atrium. You see, the walls allow us a defacing of 60 hours. Occupancy in a nominal situation is 1,000 people in the small chapel at -16, 2,000 people at the medium level, medium chapel, and 6,000 in the main church. In order to save energy, we decided to stay between 10 and 12 degrees Celsius in winter, but that means very cold walls. 6,000 people will help us with 1 megawatt sensible and latent heat, but that means also almost 1 cubic meter of water, vapors, in the main church. And because the walls are cold, we were obliged to ventilate. It's a picture of the present situation. Interior architecture has been started, and the first 3 important religious services has been accomplished, because we are in Serbia, a very close and friend country to Romania. May I say that there is the first religious service with Bartholomeus of Constantinople, and second with the Patriarch of Patras, and the third with the Bishop of Rome. Here it's present with our Patriarch Daniel and our President Klaus Werner Johannis in the right side, in front of the So we have zones. I will not insist. Occupancy, it's nominal occupancy. Our Patriarch wants to bring all Romanian from Canada, United States back. And because they are no more able to speak Romanian, there will be religious services in English and French as well. It's mostly a cultural approach, not only engineering approach to this building. About excellent question asked by Thomas, here present in front of us, and about the energy balance and the energy analysis. First of all, the main season for us designers in this case is winter, and the biggest problem is to heat this space without huge consumptions. That's why we decided to make a calculation finally on 2 zones, the comfort zone being heated mostly by radiation. So we put radiative panels, and we have also high temperature electric radiation. When we'll have nominal occupancy, we must ventilate, because 6,000 people are producing a lot of CO2 and VOC, especially in winter. There are the closings of the maybe not so rich people. And it's also the condition to bring the whole space in 2 days at 18 degrees Celsius for special services. And we made a dynamic computation for this. Finally, we must heat a little the walls. At least the first half a meter will increase in temperature in order to keep 18 degrees for 1 whole day. We are simulating here a little the positions of the radiative panels, position of the radiative high temperature radiants, and because the dome in winter is producing very cold air drafts, we, if needed, will use also some radiation at the top level to cut this. It's very unpleasant situation in many churches in winter. Of course, there are zones here, and there are airflow rates, there are air handling units. It's not time for this. Everything has been computed according to normal European norms. But we'll use them only in case of high or medium occupancy. Initially, we tried to keep the heat emissions, especially the water vapor emissions, at the lowest level, because we decided to have an up-down ventilating system. We cannot use displacement or down-up ventilation in winter in such a space. But on the contrary, for summertime, we can use natural ventilation without fearing that condensation could occur on the walls, because it will be warm weather. And because we stay by 35 degrees Celsius in Bucharest as nominal summer temperature, and the average is 28, we can hope that we can keep this space at 28 without cooling too much. We speak only about dehumidification in high occupancy situation. For this ventilating, we made simulations. It's important in winter season to have the fresh, warm air in the comfort zone with less than 0.2 meters per second. These simulations have been made with software developed by our colleague Andrei Livchak in the Halton Group in the United States, in Jacksonville, Kentucky. And they are very good. Andrei Livchak is the son of a great professor in Russia dealing with rockets, Professor Livchak. They know something about jets. It has been very difficult to find locations, positions for the air outlets. This is the second simulation for the apsis. Apsis must be especially ventilated because there is a huge surface and a lot of people there. And you can see correct velocity in the comfort zone less than 0.2. This is how the jets are looking. They are 50 meters long, and the air diffusion outlets are motor regulated, so they are adjusted automatically for warm or for cooler air. In the medium chapel and the small chapel at -16, we are using normal grills. When maximum occupancy, will have also cooling loads due to internal gains, and we must cool even in summer. Conclusions? That's okay, that's my time, ready. Conclusions are written here. You cannot explain 10 years in 10 minutes. That, I apologize, it should be enough, but I'm waiting for some questions, if some, and we discussed only a very small part of the project without explaining about heat pumps, absorbers, cooling heating plants outside, no gas pipes in this building, any gas pipe, very few water pipes in this building, only for the wet groups. And thank you very much for your kind attention. Questions?
Any questions?
We are kindly inviting you to visit this, but for the HVAC systems, it's only at the level of tendering and bidding. May I tell you that I am a very I'm deeply honored by your presence. It's the first time that we present some results about this project. Not in Romania, but in Serbia. The first time we speak about it. May I continue with the second presentation, even shorter, because tomorrow we must leave at noon. Thank you so much. I have something in the bar here, PowerPoint. Oh, here, yes. Or rather, I want to try to have some humor, because a project over 10 years cannot be paid, and because we must pay wages to our young engineers, we were obliged to design also other buildings in between in order to finance the big project. Yes. Because the remakes were 4 or 5, 6 in this time, and now the car park will be transformed into another religious space of 7,000 people. Only to say that financing and conception have changed a lot. The second work is about sports halls. We are now building a lot of sports halls in Romania with European financing, and we try to keep also the consumption, energy consumptions at the lowest level, and to use regeneratives. That's why I dare to present this to you. It's another project manager, Mr. Preda, dealing with the sport hall in Oradea. Oradea is Grosswardein in German, is Novgorod in Hungarian. It's on the Hungarian border. This is the beautiful facade. It's not so well oriented because it's toward west, okay? The most difficult restriction is to keep 0.2 meters per second in the whole comfort zone and on the sports ground. It's imposed by the European federations, volleyball, basketball, handball, especially volleyball and basketball. They consider that more than 0.2 meters per second could influence the results.
If you play badminton, also it's important.
Yes.
Yes.
So the indoor parameters are the normal ones in European projects, with this 0.2, 20 centimeters per second, but the ±5 is a normal tolerance which shouldn't be used in the computation. It will occur in the normal functioning because of other may I say reasons, which cannot be imagined even now. The whole computation is made on a very simple assumption. With the solar gains at the roof level and the lighting gains, we can solve the problem at the roof level. But we must concentrate ourselves on the occupants. And if we have 80 watts or 90 watts per person in a sport hall activity, we must supply the fresh air, if we ventilate with fresh air only, with delta T supply 8 or 9 Kelvin. It's a huge difference. I made a computation somewhere here in the picture. And so we are trying to analyze existing systems, and in the 60s, well-known Professor Linke from Rheinisch-Westfälische Technische Hochschule Aachen in this time introduced the down-up ventilation systems for auditoriums and sports halls. Because the delta T supply must be 3 in order to respect the comfort, thermal comfort, especially for the ladies, the total airflow rate must be much higher. So 30 cubic meters per hour and person, that means normal fresh air rate. And we must recycle 2 times more. So recycling rate is 2 to 1. And we must supply 90 cubic meters per hour and person. It's impossible to keep 0.2 at the comfort zone level with this wonderful old system. Okay. So we tried also simulations with normal jets over nozzles or grills or whatever, and the velocity in the axis is always higher than 0.5. Also because of the Archimedes forces, because delta T, even in this situation, must be 8. Archimedes forces are very dangerous in the up-down ventilation systems. We speak here about 12 to 16 meters zone difference. That's why finally we were obliged to search in the new technologies, and we tried all kinds of swirl diffusers. Swirl diffusers are a very good option, but nevertheless, with the delta T8, we are still in such a simulation. We are still at 0.25 on the whole surface. This is in 3D, a simulation how it could be if the stance would be horizontal, because I have no time to make a real fluid dynamic simulation, and then not money for this. Finally, we reduced the delta T supply to 5. And then we reached 0.2 meters per second. But that means we reduced also the cooling load of the fresh air supplied, and we must compensate this cooling load, missing cooling load, with something. It's nothing special. The theory says you should use air-water systems. But if we use air-water systems with fan coils somewhere, we'll have again more than 0.2 meters per second. Then we tried to search a solution with cold radiation. If it's cold in summer and it's good, we can then hope that it will be helpful also in winter, at least to keep a good temperature in this hall during non-occupancy periods. And that's why we put this German solution, or old radiative solution, Betonkernaktivierung or Betonkerntemperierung. We put pipes with water in the stairs. And we made normal calculations, and with cold water of 18 degrees, we can reach 20 degrees of the surface, and we can solve the problem. So all these conclusions showed us that using correct airflow pattern simulations, we can respect restrictions, and we can reach then maybe complex solutions. In all the cases, we are now no more all air, but air water, or air radiative, or air refrigerant. This is what I want to tell you. Thank you very much. Questions?